So as you guys saw in the previous video, after part B, my computer died. So here is part C and D of example problem 8. So C asks us for the same thing that B did if it's all nitrogen instead of oxygen. So our N value was 41.54 moles. And they're telling us that they want us to assume that it's N2, and we want units of kilograms. So, moles of N2 to grams of N2, and then grams of N2 to kilograms of N2. And so, in 1 mole, nitrogen is element number 7. Its weight is 14.01, so 14.01 grams, and there are 2 atoms of nitrogen, so 14.01 times 2 is 28.02 grams, and so 28.02 grams goes in that little space. And so give the 1 to the thing with the prefix and the metric system constant to the base unit. So moles of N2 cancels, grams of N2 cancels, and we're left in kilograms of N2. So in your calculator, 41.54 times 28.02 divided by 1 times 10 to the third equals 1.16 grams of kilograms of N2. So that's the answer to part C. Part D asks us what is the mass if the gas is composed of 21% oxygen and 79% nitrogen. So we need to take 41.54 and then multiply that by 21%, so 0.21. And then we need to take 41.54 and multiply that by 79%, which in decimal form is 0.79. So, in your calculators, 41.54 times 0.21 would be 8.72 moles of O2. And then in your calculators, 41.54 times 0.79 would be 32.816, so we'll say 32.82 moles of N2. And so just to check and make sure that these two numbers add up to 41.54 before we continue, 8.72 plus 32.82 equals 41.54 moles total. So they want to know the mass. They did not say kilograms, so we're going to go with grams. So 8.72 moles of O2. Moles of O2 goes on the bottom. Grams of O2 goes on top. So in 1 mole, we've already decided that there were 16 grams of 1 oxygen and there were 2 atoms. And so 16 times 2 is 32 grams. So 32 grams is going to go on top. So moles of O2 cancels and we're left in grams of O2. So 8.72 times 32 would be 279.04 grams of O2. And so the same thing on bottom, 32.82 moles of N2. Moles of N2 goes on bottom, grams of N2 goes on top. And so in 1 mole, we'd already decided up here that there were 14 grams, and that times 2 is 28.02 grams. So moles of nitrogen cancel. We're left in grams of diatomic nitrogen. So 32.82 times 28.02 equals 919.616. So we'll go with 919.62 grams. And if we wanted to convert those to kilograms, then we could just divide both of these numbers by 1,000 because 1 times 10 to the third is kilo. So let me know if you have any questions with example problem 8.